Application of differentiation in real life. So, what we know about differentiation in math topic that related to our daily life. Okay, now I'll be show some example of application of differentiation, which is designing vehicle. Now, you may ask that why designing vehicle have related to math topic, right? The answer is easy enough, which because we need to design a vehicle that can have excellent rate of change of velocity, acceleration, and so on. Other than that example, I also found that this math topic related to economic, which is somehow and somewhere we most likely saw it, which is trading graph. And why so? This can be seen clearly that maximum point is the profit value and minimum point is the reducing the profit. I got more example for application of differentiation, but I believe that these two examples are enough to get your mind to think of it clearly now, right? So without wasting any more time, I will give my leave and give it to my friend Terence to talk about what exactly that this differentiation calculation in our math topic means.
Thank you to my friend Carline. Okay, so based on the example given by my friend here, I'm guessing that we all already know a little bit of what exactly this differentiation things, right? But if there's anyone that's still not so sure what exactly differentiation is or why we learn this topic, let me tell you guys the simplest way to understand this, which is differentiation is the process of finding the value of function or algebra, aka variables, which is x, y, z, or any of the alphabet. This topic wants us to understand the process of how manipulating the algebra to find the variables we want. Let me visualize this topic with some knowledge that I've learned from my lecturer before we jump to the question we've been given to present. So first, every time there's variable with powers of 2, 3, 4 and so on, then we need to multiply the power to in front, and each time the power bring forward, then we need to minus 1. And yes, even though the power of variable was negative values, there's no plus 1 for that, just minus 1. Okay, that's tips number 1. Tips number 2, as I already explained, algebra manipulative, right? Only the algebra or variables can be used in this equation solving. What I mean is, if the number doesn't have any variable with it, then the value will be 0, even though the number have the largest number you've seen before. Last tip I've got, each equation can be a substitute if we already got the values of certain variables. For examples, after using EQN method in scientific calculator and get the value of x1 and x2, then we can use the values of x1 and x2 to substitute the equation that contain x variable so that we can find the other variable in that equation. Maybe it's y or z, depends on the equation itself. But we must remember that this substitution method can only works when it's only have two different variables in one equation. As long as you already got the first variable values first, then you can get the second one. Now let's proceed to presentation of our differentiation question given by our madam, my friend Will Brian. Gonna explain the first step and next step for each group members.
Question 5. So first, we need to multiply all of them and form one equation. And the equation will become 3x cubic plus 5x square minus 2x. And then we use the equation to find the dy over x, dx, and it will become 9x square plus 10x minus 2. And then we use the dy over dx and turn it to 0. So when dy over dx equals to 0, the x1 will become 0.1730 and the x2 will become negative 1.2842. After that, we substitute the x1 into the y equation and the answer will become negative 0.1808, and for the x2 we substitute it again into the y equation and the answer will become 4.4607. So the stationary points are 0.730 and the y axis is negative 0.1808 and the second point is negative 1.2842 and the y axis is 4.4607.
In step 2, I'll be using the formula being made by my friend Will, which is dy over dx equal to 9x squared plus 10x minus 2, and enhance the formula to d square y over dx square formula. In this formula, I will bring forward the power of 2 to in front to multiply the 9, which get 18, and the power value of 2 will minus 1, and now it's x to the power of 1. Then the same step for 10x, which is bring forward the power of 1 then minus 1, and the x will be just 1 times 10 and get just 10. So how about the minus 2? Okay, so minus 2 doesn't have variable, so the value to 0 value. Now we see the right side first, which is the value of x1 and x2 that again my friend will get from the previous step. So we change the x values in 2 square y divided by dx square equation to 0.173 and get y equal to 13.114, and repeat the same step again, but this time using the x value of negative 1.284, that again get y equal to negative 13.112. And now I will show the more simple way to look the x and y values. From the y values we get familiar, we can list that 13.114 is greater than 0, which is minimum point in our graph later. And next, y value is negative 113.112, which smaller than 0, and we label it as maximum point for second curve in our graph.
And now we will calculate the value of y by using the value of x that we got earlier from our calculations. And how to do this? So we will do it by substituting our x value into the equation of y, the y equations that we were given earlier as equations. So for example, negative 2 substitute into the y equation and we will get 0. Negative 1.284 substitute into the y equation and we will get 4.4607. Substituting 0 into the y equation and we will get 0. 0.173 substitute into the y equations and we will get negative 0.180. Substituting 0.333 into the equation of y and we will get 0. That is all for the step 3, and moving on to the next calculations.
The next part is the graph. Before that, here is the table of the coordinates for the graph. This table will include all of the coordinates of x and y axis. By referring this table, this is the final graph. The maximum points are at coordinate negative 1.284 at x-axis and 4.461 at y-axis. Minimum points are at coordinate 0.173 at x-axis and negative 0.181 at y-axis.
For conclusion, I think there's nothing to say much. Just be sure to double check each steps after then calculate it. and be patient with topic, I guess, because this topic requires so many calculating steps to find the answers, and much more formula needed to be used to make it done. That's all from my team. Thanks for the time you spend on our video. Ciao.